Just getting everything set up here. So just give me a little bit, give me a few minutes here. It says it's good, so I'm not gonna touch it. Pretty good view that we got going on here. That's a lot of stars, so I cranked the gain up as much as I could without it blasting out the image. So we'll see. We still got a long way to go. And where I'm shooting this is Navi. It would be the star that would be, I got too many. It would be that star right there. That's Navi right there, and then that's that one right there in the red. That bright star. I'm trying to charge my phone too at the same time here, so give me a second here. And I'm using the backup guiding program too because the original guiding program is not working tonight. Love how things don't work when you've been sitting here waiting patiently all freaking day. So far, I don't see any meteors yet. Still got a very long way to go. I could crank the gain up just a little bit more, but I'm not going to risk it. Let me just check something real quick here. Oh, the star's looking. Not bad. Yeah, that bright star that you see there, that's Navi. I'm going to restart Sharp Cap here. Hang on. Give me 1 second here. For some reason, it wasn't taking live images, and I'm just restarting it back up. So while we're waiting for that to restart back up, Navi, that's the bright star in Cassiopeia. That's like very bright. That's like naked eye star. That's how bright that is, and that's like dead center in my finder. So you'll see that bright star there. and this is magnified at 2 times. Magnifying it fit to window, that's what that looks like there. So you can see that it's really, really small. And then you're going to get the vast field of view. I'm just waiting for Sharp Cap to pop back up. Okay. There's an airplane going right through it too. There. So then you'll be able to see the time on there of the seconds. Actually, I could probably shrink it down. There we go. You could still see the 805, I think, right? You still can see it. Let me try to see if I can raise the gamma and raise the brightness here. Yeah, there's still a lot of pixels there. All right, let me put the cap on so that way I can get rid of the. So give me 1 second here. I'm going to try to put the cap back on the. Okay, so I put the cap on, and now we're going to run darks real quick. Capture darks, start. Oh, yeah, turn. Dark subtraction off. None and start. Okay. Okay. So now what it's just doing is I'm running a dark frames. What this is going to do is it's going to take 7 70-second dark frames. I did this before, but the problem I had was I was running it under RAW, and I wasn't running it under RGB. And doing RGB for RAW is actually better, because then I don't have to pre-process the images they're already done. So, like you see here, you're seeing red, green, and blue pixels. That was what was on the image. It's going to take 7 of these, and then once it redoes the image, then it's going to eliminate all these colors, so you're going to get a nice solid image from start to finish. And then I'm going to run this for 3 hours, and then whatever we get, because right about now is when it's going to start peaking. So when this is over, then we'll actually get a chance to see it, and then we should be in good shape. Well, I need to, I got to flip the filter too, because I'm on hydrogen alpha right now, and I'm going to flip it to RGB. Do that still too. Somehow the mount lost its go-to, which I don't understand how that's physically possible. I guess apparently if something's going to go wrong, everything's going to go wrong. We should be good to go for the wide field now. Alright, cool. Now the wide field's good. Now we're going to take the dark subtraction. 70 seconds. And now, the next minute, you're going to see this go away, and now we should be in good shape. Now we'll be able to watch the meteors. Thank God. We should be in good shape now. But you can see all the noise. There's like noise to the max. Alright, so I flipped the filter to RGB, and now you can see that the noise is gone on the image, and now it's just solid stars. So now what I'm going to do is change the settings for gamma. So then you'll be able to see a little bit more. So if anything comes through, we'll see it. There. So I got this contrast going really good. Go. Excellent. So that's set. Alright, Cassiopeia is right here. Shoot, I don't know what is my mouse. Okay, no wait. Okay, it's right here. This is Cassiopeia right there. I know it's hard to see, and you can actually see just barely, the Milky Way is actually on here. Because the Milky Way actually goes right through Cassiopeia. So right now it's sensitive enough to get the Milky Way from here. So if we can get that, we can get a meteor. And the meteor the action would be like right here. So I'm hoping in the next couple of hours, this hue of light, which is from across the street, is going to go away because this is going to get higher and higher in the sky, and you're actually going to start to see a really good picture. I'm hoping. So we'll see. So, I'm hoping to get something. There we go. Guiding was up. The guiding slipped a little bit. We're back. Okay. Guiding is back. And it is still looking pretty good. We're doing really good. Move the picture a little bit. So this way, hopefully, something will show up. I'm hoping. Stop that image because that didn't turn out the way I wanted to. Although actually, 2 planes actually went through the last image. So that's interesting. So now this is going to be in red, green, and blue. So this is going to be an actual picture image, an actual physical red, green, and blue. But this one was off a little bit because I had to change the guider a little bit, so it's going to be off by just a little bit. As you can see, the stars are like oblong. So I just fixed the guider because it looked like it was slipping on the graph. But I fixed it. So we're good. So now if I take a 240-second image, it's going to be perfect. Now, I wouldn't say perfect, but light pollution sucks here. It sucks so freaking bad here. And I haven't seen anything yet either. I've actually been looking out at the sky here, and I haven't seen anything yet either. Light pollution can play a big factor. Looks like there's one at the top right of the screen. I could be wrong, but I'm pretty sure that right there, that's gotta be one right there. I could be wrong. If it disappears on the next frame, that looks like that's one. We'll see. We'll see what's on the next frame, but I'm pretty sure that wasn't there on the last frame. It would be right here. I don't know if you can see that on the screen. Here. I could be wrong. It'd be right here. Yep, that was one. That definitely was one because it disappeared. I don't know if anybody caught that, but I'm pretty sure that was one. It was faint, but faint counts. Faint does count, and that's cool. You can actually see the Milky Way right here. You can actually see some of the dust lanes and how dark it is right over there. As I said before, the thing on the bottom right, that's the Sigma lens. I have this attached to the bottom of the Sigma lens, so yeah. And it's just there. And as I said, as this gets further away from the light pollution, this is all going to become the same color. It's all going to be dark. Alright, we'll see what this image looks like. How's guiding going? Meh. Meh. The stars look pretty good. The stars look really good. This is just a 4-minute exposure. Yeah, the stars look pretty darn good to me. We'll just take a planner. Why not? Let's go for it. We still got a long way to go before we get to the Pleiades, because that's the one thing I definitely want to show everybody is M45. So, we got a lot of time for that one. Let's see here. And it is beautiful. It really is. It really is amazing. And if you look carefully, right here, this is like a light shroud. What that means is the camera's picking off a reflection off of something, and it's just showing that there's a light shroud. So as I said, as this is going to get higher and higher in the sky, this is going to get darker and darker, and the stars are going to become more prominent, and I might be able to pick off more stuff. So far, it looks like we caught one meteor so far. One. But we'll see. We'll see what happens. Still got another 3.5 hours more to go, so I'm sure some of you are probably going to be heading to bed soon. Let's see how the stars look on this image that are going to be coming up soon here. wait. In the sky. I will say this though, and I thought this was very interesting. As the sun was setting this afternoon and this evening, I looked up in the sky and I saw not one, not two, not even three, but 4 planets up at the same exact time. I thought that was really interesting. Venus was just about to set, Jupiter was bright, Saturn was right next to it, and then Mars was rising. So all 4 planets all sitting there, super amazing. Super, super, super cool. Let's see how this turned out here. Oh, pretty good. This was a 5-minute exposure. Wow. Pretty nice. The stars look pinpoint at 5 minutes. Not bad. Whew! What do you think, people? I think that looks pretty darn good. I think that looks awesome. I do have some dust on the lens. What I'll do is I will label. I'll make the word small, so this way if there's any meteors or anything. There we go. It really is some nice tracking. I mean, I really can't go wrong with this setup. What I use, and it's really weird, but it works, because I transferred it over from my CG5 onto this Celestron AVX, and what I use is I have the guider, which is the Meade DSI, and it's a color camera, not monochrome, and I have it on an 8x40 finder, and then I have it hooked up to what's called a GP USB. I know some people use their cameras to track, but I use the GP USB, and you can get that from Shoestring Astronomy. And what it does is it actually takes the cord that you plug into the mount in the guider port, and it actually goes into a box and then comes out the other side, and it's a USB. Then you take the USB and plug it into the computer. And then you take the other cord and plug that in the computer, and then it's going to talk to each other from the computer. Because then when you go to your guider, instead of clicking mount or on camera, you select the GP USB, and it has a LED light on there, and anytime it's using a correction, it'll blink green. If it's not, it's just a red solid light. And right now, I see it blinking green maybe every 30 seconds. And it just blinked green now. And I can get, with tracking, I can get between 0.5 and 0.6 on an average night. The best I've ever done for guiding was 0.27. Right now we're at 0.85 because I'm running on a backup program for PhD, because apparently the computer screwed up and I don't want to restart the computer because it says there's an instance running, when in reality I don't have an instance running. And it makes no freaking sense. So I am not restarting the computer because of that, so I'm just going to leave it as is. So I'm just running it, and the settings on the other one I can't grab onto the other one, so I'm just going to use this one as it. And it is really cool, Chris. It really is. And I know people use PoleMaster to align their mounts. What I do, and I think I've showed this to a couple people, is I actually use the Polar Cam or Polar Scope, and I use a Microsoft Life Cam that you can get online. You can get it for cheap, like a webcam. And the width of the Microsoft Life Cam fits exactly the same as the Polar Scope. So you just tape it. Just tape it up real nice and tight, and then you flip it upside down. Because what happens is, the Polar Scope is like a regular telescope. It reverses the image, so flips it upside down. So when you're looking through it, and we've all done this before, if we've had mounts and if we've had, telescopes and whatnot, and you have to bend over, look, and try to look through the Polar Scope to see where Polaris is, and then try to move the mount and get it just right, so this way you can get it, and then you get it, and then it takes forever. Well, if you put the camera on there, what you see through the camera is what you see on the computer. So it's really, really cool. And you get it just right. I use the Sky Safari app to see where Polaris is. And when you flip it upside down, it doesn't reverse the image. So then what happens is, where Polaris is in the sky is what you're going to see it on the actual camera. So you get it just exactly where it's supposed to be. Now the Polar Scope has a reticle, has a circle, and you can actually match it where the circle is, because the center of that circle is the northern celestial pole. And that's what I use to get it just right. The stars look absolutely phenomenal on the QHY. I mean, that is really good. That's a 5-minute image. And I could change the histogram, and then you can actually see Navi, which is right there. I'm just changing the histogram just so you can see it. And how bright Navi is. Which is also known as Gamma Cassiopeia. That's the histogram all the way at the bottom. And then I could just bring the histogram back up again. And there it is. And those stars, and I'm telling you, the stars that you can actually see color. Like right there, that's an orange star, a reddish star right there. There's another orange or reddish star at the bottom there. And you can even see some of the really, really faint ones all throughout here. So that's pretty sweet. That is pretty awesome. Yeah, and if I actually were to take this and then fit to window, this is my field of view. And that's... Navi is right there. I'm trying to see if I can... There we go. That's Navi there, and that's the field of view. Which, that's insane. That's a lot of stars in one field of view. What I forgot to tell everybody the last couple streams, I am using a field flattener, a chroma corrector, on the QHY, the 80mm refractor. It's a 0.8 field flattener chroma corrector. So, it's a focal reducer is what it is. What that means is, and we're going to go into telescope talk, is, and if you're bored by it, by all means, please let me know, is that my refractor is an 80 millimeter aperture. Aperture means the width of the telescope, of how big it is, okay? So 80 millimeters. Then what's called focal length. And like I talked about earlier with the Cassegrain, refractor, Newtonian, Dobson, focal length is how long light takes to travel through a telescope. That's 545 millimeters. So that is the length of the focal of how long light travels. And how you figure out focal ratio, which is called F ratio, is you take your millimeters, your focal length, and divide it by your aperture. Okay? So hence, if you take 545 and divide that by 80, I have an F ratio of 6.8. The lower the number, the better your pictures will be for astrophotography, especially for long exposure. For planetary, it's the exact opposite. You want the highest number possible, so F30, F35, F50. That's why Cassegrains are so good, because if you have, say, a 10-inch Cassegrain that has 3,000 millimeters in focal length, naturally that's going to be a lot higher than something that you would have here. Now, as I said, they make focal reducers, which is what I have. And it's a focal reducer by 0.8. Okay? So if mine's a 6.8 F ratio, you're taking 0.8 off of it. So it's actually a 6. If that makes sense. Okay? So if it's 6, it would be 80 times 6, which is actually 480 millimeters. Which means, in turn, that if it's a shorter number in your focal length, you're going to get a wider field. Does that make sense? I hope so. So that means by putting on this focal reducer, I now can get about 10% more stars than I would without it. And also, it being a field flattener, the corners don't look like they're getting chromatic aberration. I still have to fix it, because the problem with that is it's all about distance. No, not all about the base, but there is no treble. But with the distance, is just like how you have to get a telescope in focus, you have to find the right distance between the sensor of the camera and the field flattener. If it's too far out, you're going to get a warped image, meaning that you're going to get like a bow effect on your image. So if it's too close, same thing. You got to get it just right. And you can find it online. I know that with mine, it was like 55.2 millimeters from the sensor. So you got to get spacers. They always get you. They always seem to get you, because I don't know, Chris, if you've seen it before on how much spacers are, but it's ridiculous. Because you got, and they make different ones. There's 2 millimeters, 4 millimeters, 16, 20. You got to find the right combination and get them just right, so that way there is no coma. And I've been fiddling around with it for God knows how long, trying to get it just right. And I'm oh so close. So like, this is the top left here. This is the top right. So you can see it's so close. This is the bottom right. This looks really bad. And this is the bottom left. I gotta get it by like 1 or 2 millimeters. But you could see that the middle is absolutely perfect. So you can see how that happens. So that's how it works. And I know it's scientific, and I'm sure there's a lot of people out there that are probably like going, I don't understand. I'm confused. But that's how it works. And that's, you gotta find the right way. Is that a plane, or is that a shooting star? Please tell me that's a shooting star. Tell me, people, do you see it or do you not see it? Is that a shooting star or no? Yeah, it sure as hell looked like it to me. Was that a shooting star? Man, everybody's live tonight. P&K Space Imaging is live. Astronomy live stream is live. So the live is live. Everyone's live, and everyone's getting good stuff. So let me just see. Yep, it is. That's definitely a shooting star because I'm looking at it. I went back 2 frames to see. There's no connecting dot. Like you would see if like a satellite was going through the sky, you could actually follow it going like a dashed line all the way through the sky. There is none, 0. And usually when you actually see it, it'll actually fade in and fade out. And that's exactly what this looks like, is it fades in and fades out. And this happened at 1:15 a.m. Awesome. Yeah, it's looking really, really good. You might want to bring up the brightness just a little bit more. There we go. This way you'll be able to see it just even better. Those 2 dots that you see there, right here and right there, that's probably because I put the lens cap on. It probably had like 2 dust specks on it. So that's my bad. That was probably my bad, and I didn't mean to do that. I also fidgeted with the guider, so you can actually see how bad it moved. Whoops. And it does look like a good night to capture a double cluster if my freaking Go-To would work. I mean, I could try it and see. People, should I give it a shot? Should I give it a... I think I should give it a shot. I think I should. It's down there. Here's what I'm going to do. I'm going to restart the mount. Alright. So here's where we stand right now. I'm going to reset the mount. And we're going to get it to where it's supposed to be. And I think what I'm doing right now is what you're seeing now is me realigning the mount. So I'm just getting it set to the 2 brightest stars in the sky right now. So the first one was Mirfac, and then this one is Capella. So these are the 2 brightest stars in the sky right now, and I'm just making sure that they're centered. Now we're centered. Now I can go back into Starry Night, and then now I can use telescope control. Now it should work. There we go. Now we got it. Okay. We got it, people. We finally got it. There's a bug on my hand. Good Lord. Okay. That's perfect. Okay. Oh, so the mount was just completely screwed up. That's all it was. So Chris, you were right. The mount was completely screwed up. So now we are set. Now I can take an image off of this thing. And this is going to look amazing. Let me go to focus. Let me see how good focus is on this. Focus is not bad. 17, that's not bad. Now that should be perfect. Especially when you have star clusters, you want to make sure that they are absolutely pinpoint. This is going to be a lot of stars. This is going to be really cool. Probably during editing, I will take out most of this. Yeah, this is going to look good. Okay, so now you can actually see the cluster actually in the guider too, which is amazing to think about. Okay. Guide off of that. Okay. Should be good. Then we could take... We'll take 100-second exposure right now just to see what it looks like. Trying to find a good start to calibrate on here, so just give me a second here. I think I found one. COP is still there. I'll make this bigger. So this way you can see it. There you go. That's amazing. That right there, that's the double cluster. That's awesome. AJ is watching it from VR headset. That is really cool. And what I'll do is I'll type in and what this one's called again is Chai Perseids, aka the double cluster. Whoops. Whoa. Put that up at the top here. Yeah, I'll put it at the bottom. Okay, there we go. Chai Perseids. And it fits really well in this camera, so that's really, really cool. Christy, I see that you're still watching. You were right. The mount just needed to be reset. Apparently, it just lost complete control of where it was supposed to go in the sky. I don't know. I have no idea. It found one star but couldn't find another star, even though it was slewing back and forth and it couldn't find it. But once I reset the mount and then locked it on the two bright stars, it found Chi Persei immediately and had no problems at all. None. So I have no idea. I don't know. But let me zoom in so you can really get an idea of what this looks like. How amazing this is. And that is just... And this is one cluster here, so you can get an idea. So that's one cluster, that's on the right-hand side. Then if you go scroll over, and then you scroll down, then you'll be able to see the other cluster, which is right here. And you got the red stars, and you just got everything. Just the detail is just incredible. And what I could do is I can crank the exposure just a little bit more. So I could probably do 300. See what it looks like. So I apologize to anybody that's still watching. I apologize for a lot of things that have gone on so far up to this point. I'd say 30% of it has gone really, really, really well. 30% of it has gone meh. And 40% of it, you can just throw it in the garbage. Because it was just absolutely terrible. And actually what I'll do is I could probably... You can actually see it in this view here. Which is really cool. It's like right in the middle of the finder. Whoops. Oh boy. There you go. That is really cool. Well, at least something went right, people. At least something went right tonight. Somebody was jamming out. Let's make this a little bit smaller so that way we can go back into Perseids Watch. You got Perseids Watch and Chi Persei. There's Perseids everywhere. Perseids all over the place. And when that image just comes up, I'll make it bigger and then you can see it. But now see, if the night went like this, then I'd be happy. But naturally, nothing ever goes right. And it really is looking good. Thank you, AJ, for stopping in and checking this out. And I do have nice photos for stacking, which is great. I'm just taking a preliminary 300-second image just to see what it looks like. And if it's good, then we're going to take a plan of it, and then we'll just go from there. Because I'd like to take, I'd say 6 or 7 of these, if there's no drift. And guiding is okay. Guiding is alright. So far, there's no shooting stars. I don't see anything yet to this point. I don't see anything. Much brighter. The stars didn't move. But we're taking a plan. We're going for it. Alright, we're taking a plan. We're going for it. Max actually, and that's a great question, AJ. Max actually physically happens tomorrow. Well, technically it's Saturday going into Sunday. It's the 12th going into the 13th. The only reason I'm out here till 4:30 is because tomorrow is supposed to thunderstorm. So tonight we're clear. I'm going to try to get as much as I can now, because this is the time. This is it right here. Between pretty much now and like Monday morning is going to be like you're like going up and climax and then going back down again. So this is going to be it. And if you're at a dark sky site, which I'm not even close, if you're at a dark sky site, you could see anywhere from 120 to 150 per hour, which is amazing. So tonight is not the max, but you're still going to get a decent amount if you're at a dark sky site. And yes, Sunday into Monday is max. So you'll be able to see it from there, which is great, but we've already gotten 2 or 3 so far tonight. And knowing that it's, past 2 o'clock, it's very possible that we could see more. It is very, very possible. There is a little bit of a light shroud right here, but that's because if I scroll up just a little bit, you can see that I'm across the street is where there's a ton of light. They got their lights. There's businesses across the street, so I can't turn their lights off, unfortunately. I wish I could. And then at the bottom left, I'm doing long exposure. I'm doing a 5-minute exposure of Chai Persei, which is the double cluster. This image should be just about done here on the bottom left. Now this is from the planner, so it's going to be a little bit different. I'm just going to change the histogram here. Yeah, that's looking really good. That is really good. And whoever's watching, just make sure that if you guys haven't done it already, make sure you're subscribing to the channel and also hitting the notification button, so this way you know when I'm going live. I plan on this upcoming week, if it's clear during the day, I'm going to be doing solar. I'll be getting the sun. So look out for that. So if it's clear on either Tuesday, Wednesday, possibly Thursday, I'm going to be out there and I'm going to be getting the sun. And that'll be really cool because I have the equipment for that. It's just a matter of time of just waiting for it being clear. Somebody else was jamming out to music. Who's driving around at 2:30 in the morning?